Hi all. So welcome to our webinar. Thank you for joining today. Today we're going to be talking about building serverless applications with AWS's Amplify and AWS's AppSync. So presenting today is myself, Ben May. I'm a solutions architect with ClearScale, and my background is in systems engineering and management. At ClearScale, I support both the sales team and client projects. Daniel, would you like to present yourself?
Sure, thank you, Ben. Hello, everybody. My name is Daniel Kim. I'm a solutions architect at AWS, supporting our APM partners with their technical development and building expertise on AWS. And my area of focus and specialization is on helping customers modernize their workloads using serverless architecture. I'll turn it over to Steve.
Hi, my name is Steve Johnson. I'm the AWS tech lead for mobile. I work a lot with customers building web and mobile applications, and certainly with serverless tools like AppSync and Amplify.
Great. So we all should be familiar with who Amazon is by now. So I'll present ClearScale. ClearScale is a AWS Premier Consulting Partner. We started in Silicon Valley in 2011, and we've completed over 850 projects for more than 250 Amazon customers. We have 10 AWS partner competencies, such as mobile, IoT, DevOps, and SaaS. And our engineering team holds over 100 AWS certifications. Please note that towards the end of this presentation, there's going to be a Q&A time. So you could ask any questions during the presentation, and we'll make sure to answer those at the end of the presentation. Great. So we'll get started with the overview of modern application architecture. So I'll hand it to you, Steve.
Okay, thank you. So what we're going to talk about now is, as the slide says, modern application architecture and what that actually means, right? The characteristics of a modern digital business include not just the technical elements of your architecture, but sort of a way of looking at things, a way of looking at building your applications. One of the things that digital businesses or born in cloud businesses are really good at is customer obsession. Everybody sort of realizes now your customers are the lifeline to your business, and the very best companies are customer obsessed. Also, because of the competitive nature of these businesses, you have to be organized for value, right? You can't have high margins, and you need to make sure your resources are used in the most efficient way possible. Sort of competing with that idea is this test and learn culture, right? You need to be able to iterate and innovate and move quickly, fail quickly, and arrive, at the best solution for your customers. All these things are made possible. Good customer experiences, delighting your customers, are made possible with technology at the core. Now, years ago, it used to be that companies would build their own algorithms. They would stand up their own servers, and that was part of their IP, right? The fact that they could do any of this made them competitive. Now, technology is so ubiquitous and so shared amongst you and your competitors. The important thing is to have super reliable technology at the core. But that's not your IP, right? Your IP is going to be everything above the technology stack. And lastly, in order to really connect with your customers, you need to make strategic use of data. I guess it's no secret that the best companies now are collecting quite a bit of information about how their products are used, what their customers like and what they don't like. And it's getting to the point now where we can tailor experiences to individual customers and make sure we're making the most of keeping customers that we have and attracting new customers. The last thing I want to mention is, these are all attributes of, what I mentioned before is born in cloud businesses, but that doesn't mean that established businesses can't take advantage of these, right? We have customers like, a good example is McDonald's, who has certainly been around for a long time, and they implemented their home delivery in 4 months, scalable to 1 million orders per hour. So doesn't matter how established you are, doesn't matter how much legacy technology you have or anything else. If you're willing, to apply these principles, you can do amazing things. Okay, so when Amazon talks about serverless, there's 4 things in particular we're talking about. First of all, not surprisingly, you'll have no servers to manage. Sometimes our serverless offerings are called managed services as well. So there's no installation, maintenance, patching, that sort of thing. You just don't worry about it. Next thing is flexible automated scaling. All of our serverless products are designed to be used at scale, at Amazon scale, cloud scale. We use, not surprisingly, a lot of our own products in our own products. And so we're pretty sure they're ready for production, when we offer them to our customers. Next thing is pay for value. Instead of, we try to make sure all of our serverless offerings, you only pay for what you actually use. And there's a couple good reasons for that. The good reason for you, obviously, is that you're not paying for things you're not using, right? You're not paying to keep a server warm someplace, right? Even if it's not being used. But it also allows us a really good insight into how our services are being used and how to optimize them over time, which includes optimizing services for cost. And once again, automated high availability, somewhat related to scaling, but we make sure there's as little downtime as possible, and we're really proud of our uptime record for all our services. Okay, so how does this change how you work? For builders, because we talked about an iterate and fail culture, hopefully iterating quickly, failing just as quickly until you find the right solution, you can start building serverless architectures from scratch, right? Because they're so easy to stand up and so inexpensive to stand up, you can run through proof of concepts really fast, prototypes really fast, and iterate until you get something really innovative and exciting for your customers. On the operations side, instead of standing up servers, ordering hardware, turning wrenches and patching operating systems, the operation side of things is mostly about deploying from a CI/CD pipeline, doing that really efficiently, monitoring operational data to make sure availability, scalability is where you expect it to be, and basically keeping things running as smoothly as possible, as opposed to building everything from scratch. Okay, we're going to do a demo in a little bit, and for now, I'm just going to talk about some core mobile services on AWS. Excuse me. So a lot of our customers, when they start using serverless, especially if they're building a web or mobile application, they'll use these 3 services. The first of which is Amazon Cognito. That's our fully managed identity pool and security solution. It's built on top of identity and access management, which is a core security service that is integrated into all of the AWS services. Cognito, you can use it standalone as an IDP, or you can federate it with social providers, SAML, OIDC, and it generates its own OIDC compliant JWT tokens. Those tokens can be used natively with API Gateway, which is our REST API solution, and AWS AppSync, which is our GraphQL solution. It works closely with the AWS Amplify libraries, and of course, enterprise security is built in. The next element is AppSync, which is our managed GraphQL service. Just about all web and mobile applications use an API layer of some point. We're seeing a lot of interest around GraphQL for a lot of reasons, primarily because it's based off of a schema. You can clearly define what operations are available and even define what data is returned to you and in what shape. And lastly, that API layer is usually matched up with DynamoDB. There's some very good reasons for that. It's fully managed and serverless, and it's also extremely fast, right? So you have millisecond level access to data, has some advanced features like primary and secondary indices. You can have transactional API calls, which is good to have on a NoSQL database. And it integrates with AppSync natively, meaning you can generate all of the code and all of the database tables you need from Amplify. So I talked about Amplify a little bit. Let me just cover what that means. If you're not familiar with Amplify, it's AWS's solution for web and mobile development. And it's actually built on a couple different legs here, the 3 legs of Amplify, as I like to call it. First are client libraries and components that you can add to your client side or front end. We actually support a lot of different platforms from iOS, Android, Flutter, React Native, React, and other JavaScript platforms. We have something called a tool chain in CLI, which I'm going to show you during the demo. It allows you to build your backend, even if you're not very familiar with AWS. It'll build a best practice production-ready environment for you and your application. And lastly, we have a build and deployment service called the Amplify Console, where you can connect your code repository to the console. It will automatically detect changes, build, and deploy your websites for you. And if you want to bring it all together, here's a little bit of an eye chart. But if we focus on the front end, you'll see the mobile and web application is talking to AppSync as the API layer. We're using Amplify libraries to access services like the Cognito user pool. And the Amplify CLI at the bottom left there, that is how developers can actually build their cloud stacks using CloudFormation. So by using a combination of Amplify and these services, you have access to the entire AWS cloud. It's all integrated, it's all secure, scalable, and available. Okay, now I'm going to hand off the presentation and we'll talk about database services.
Great. Thanks, Steve. So going into databases, in modern application development, we look at using databases tuned for specific jobs. On-premise, this would be very expensive. You'd have to set up your own machines and pay for licensing and manage those systems. But with AWS, you pay as you go, and these systems are managed for you. So this allows your development team to correctly choose their technology stack. So when we look at this list, we're looking at a couple things. We have first relational databases, which are our standard databases we use and are used to seeing. So MySQL, Microsoft SQL, Postgres. These databases have data items with predefined relationships between them. And then we have our non-relational database, or NoSQL databases. Essentially, every other non-SQL database span across many use cases. So the first one is key value store databases, which are databases that store data in a key, and each key is associated with only one value. And these values are usually stored as a blob. So it removes the need to actually index those values, and it makes it very quick. So they're typically very quick databases. And a couple examples of key value databases are Amazon's DynamoDB or Couchbase. Then we have time series databases, which are databases optimized for time-stamped or time series data. They're used to quickly measure changes over time at a large scale. So for an example, we'll use Amazon's Timestream database. And then we have graph databases. So these use a graph structure with nodes of data that have edges that connect to relating data. This is used for systems that need to fast query many-to-many relationships. And Amazon has a database that we'll talk about called Amazon's Neptune. So the first one we'll look at is Amazon's DynamoDB, which is a NoSQL key value database. And it delivers single-digit millisecond performance at any scale. Each value, you could store up to 400 kilobytes of data. And this is fully managed by Amazon. So you don't have to manually scale or back up your database tables. And DynamoDB's throughput is pretty insane. It can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. And the database is ready for any enterprise. It has full end-to-end encryption. It's encrypted at rest, and is compliant with almost any workload. All those compliance certifications are provided by Amazon. Now, on the first line, we talked about fully managed. And so what does this mean? On site, there's many tasks that are now Amazon's responsibility. Steve mentioned a couple. He went into serverless, but for DynamoDB specifically, we could kind of poke at a few of them. So Amazon manages the security by doing the system patching and audits, along with the encryption and compliance maintenance. So you're now abstracted from all of the security workload that your team would normally have to take advantage or take care of. Amazon also manages the availability by making sure that DynamoDB is backed up to multiple data centers and that the system is always up and running. And to make sure they're up and running, they manage the durability of this. So they make sure that the underlying infrastructure can manage failures and gracefully fail over to any backups that they have of your data. And then we look at how they manage scalability. They look at how much capacity is needed for the customers on that area, and they ensure that the data is a location that has enough capacity that you could scale up quickly without having to be moved to a different system with more capacity. Amazon manages all of this for you. All you do is you say, I need a table, and I'm going to put data in it, and Amazon does the rest. So now let's look at Amazon's Aurora. So this is the relational database provided by Amazon. So it has MySQL and Postgres compatible relation databases, and these are really built for the cloud, or Aurora is built for the cloud. So Amazon has combined the performance and availability of traditional enterprise databases with the simplicity and really the cost effectiveness of open source databases. So we look at this as a typical drop-in for your MySQL and Postgres databases, but you're running this on Amazon's Aurora platform. And with that, you have some great things. You have 5 times the throughput of standard MySQL and 3 times of standard Postgres, and it allows you to scale up to 15 read replicas. So you could really scale out if you have a ton of reads on your system. And it's completely highly available and durable. So it's fault tolerant, self-healing. It keeps 6 copies of data across 3 availability zones, which in Amazon are what we call data centers. And it continuously backs up to Amazon's S3, which is their object storage. Amazon manages all the encryption at rest and in transit, and makes sure that all of the compliances are met and all of the audits done on the system are handled by Amazon. And then lastly, it's fully managed, so you don't need to do any patching, setting up of the database, configuring. You just say, I need a database, I need this much CPU, I need this much RAM, and you get started. Now that's the, Aurora's managed service. And they actually have a serverless offering also. So instead of saying, I need this much CPU and this much RAM, you say, I need this many database connections, essentially. So they'll manage the scaling for you. They'll look how many database connections and how much CPU you're using. Should we add more resources to this machine? So Amazon will manage that for you using Aurora Serverless. They'll also shut down your machines for you. So if you have machines that are running in a development environment, let's say you have a dev 2, a staging, and then your prod. Well, those other ones, you don't need to be running big bulky machines. You can have them essentially turned off until you're ready to use them and test on those machines, and then pay for only the time you're using them. Amazon manages, it'll see the connection come in and spin up that resource for you. And always on production, you could tell it to not ever shut down, so it's always hot and ready for your team to go. And if we look at how Aurora is set up, they manage the scaling by keeping a warm pool of instances off to the side. They look at how much you're using, and then as you start to hit certain thresholds, they'll move your information over to these other machines and get them ready to handle the read and write. When they scale up, they look at long running queries for you. So you're not having to, stop a query or stop any sort of connection. It'll wait until that job is finished before switching that over to a larger instance. So the serverless really manages all of that connection for you, and you don't have to worry about, your customers being dropped while you're scaling. And really that goes into, less to worry about. So you don't have to look at, how many CPU credits you have to look at with kind of managed services within Amazon. You don't have any commitment to a particular availability zone or data center. You don't have to look at when new instance types or new computer types are released. You don't have to look at changing to those, and upgrading. Amazon manages that completely for you. You don't have to worry about the encryption or stopping databases when they're not in use. All of that is managed by Amazon, and I think it's a given, but the DNS is also completely managed by Amazon. You just hit one endpoint and they scale everything behind the scenes for you. So now let's look at the Amazon's Timestream. So this is a time series database, typically used for IoT or operational applications, and it makes it easy to store and analyze trillions of events per day, and it's about 1,000 times faster and a fraction of the cost of relational databases. And this is where we go into those purpose-built databases. If you're using relational database for everything, you might just be paying a lot of money to use a database that isn't built for what you're doing. You might be able to get it to do what you need it to do, but it's not built for that. So you could be wasting resources. So you look at this, and it's 1,000 times faster at one tenth the cost because it's built to do time series for you. Timestream actually has built-in analytics also with native aggregates and window functions. So you don't have to bring that out and compute it somewhere else. You could run it directly on the database. And this is also a serverless offering by Amazon. So you're not having to manage any systems or manage any of the scaling. You pay for what you use here. And then last is Neptune. So Neptune is a fast, reliable, and fully managed graph database. It's a service that makes it easy to build and run applications that work with highly connected data sets. So it's a purpose-built, high-performance graph database engine that's optimized for storing billions of relationships and querying the graph with millisecond latency. So this supports normal or popular graph models like Property Graph or W3C. And it has 15 read replicas similar to Aurora, and it's a pay-as-you-go model. And I have a customer use case to show you how we used this graph database with a lot of success for them. Great. I'll pass it over to you, Dan.
Okay, thank you, Ben. So I want to continue talking about the serverless services that we have in building modern applications. Steve talked about some of the mobile related services, and Ben talked about some of the database related services. I'm going to talk mainly about our core service, our own serverless, which is Lambda, and the messaging services that relate in building an event-driven architecture, which characterizes our modern architecture today. So our modern architecture can be characterized by having a loosely coupled distributed services, and as I mentioned, event-driven, and having a serverless component as part of the architecture, which allows the teams to be able to offload the heavy lifting and allow customers to focus on delivering value to the customers. So Lambda is at the core of our serverless offering. So it is an event-driven compute service. We launched Lambda in 2014, and since then, it's the largest and most established compute service that we have today. And in this case, serverless compute model typically comprises of 3 components. It's got the event source and triggering of the Lambda function, the actual logic that's implemented in the Lambda function, and whatever the Lambda function needs to do to carry out the logic, whether it be having a transaction with the database or calling out another service. And an event source, in this case, could be anything from an HTTP request through API gateway, or an event response by putting in objects into an S3 bucket or DynamoDB insertion. So, and also pulling things out of an SQS queue. So All of these lead to triggering an event and calling the Lambda function to carry out the logic. And the Lambda function you can build with virtually any kind of language that you choose. Out of the box, we support these languages such as Node.js and Python, but we can also run custom runtime as needed. So you can perform whatever business logic that's needed at the convenience of using the language that you prefer. And ultimately, you only pay for the compute time that you consume and run compute without being able to provision servers or manage servers and be able to scale automatically. So with serverless services such as Lambda, you can easily build these event-driven architecture that drive reliability and scalability. And these events are asynchronous, which means that you don't need to wait for a response to move on to the next step, which reduces that dependency and improving the resilience of your architecture. And the key component of the event-driven architecture are the messaging services that allow you to abstract the producers and the consumer, by decoupling the services from each other. So I'm going to go over some of the primary messaging services that we offer at AWS and how you can utilize these in building your serverless architecture. And three of the most useful messaging patterns that we see in serverless developers use are queues and PubSub and event buses. But what we have here is Amazon SQS. Which is a messaging queuing service. So it allows you to use a queue to send, store, and receive messages between the different services. And queue is an important mechanism for providing that fault tolerance in a distributed architecture and helping you to decouple the different parts of your applications. And most importantly, it allows you to durably persist messages until they are processed by downstream consumers. So SQS also allows you to scale elastically. So there is virtually no limit to number of messages that you can store in the queue. For example, we were able to handle approximately 25 billion requests per hour during our major events such as Black Fridays or Cyber Mondays. And SQS also has a FIFO, which is a first in, first out version of the queue, which allows you to preserve the order in which the messages are received. So this will be a use case if you have a use case where you need to preserve the order. FIFO SQS offers the FIFO options. Simple notification service is another messaging service that we have. It's a publish subscribe messaging service, and you can publish and subscribe to targets such as HTTP, SMS text messaging, or mobile push notifications. And the difference between SNS and SQS is that SNS allows you to broadcast to multiple targets, a behavior which is called a fan out behavior, which and also enables you to send messages reliably between the different parts of your app infrastructure. And another difference of SNS between SQS is that it doesn't retain any messages, but it does offer a robust retry mechanism when the downstream targets are not available. And if there's an error or if the downstream targets are not available, you can also have an option to send these messages to dead letter queue, which you can pick up the messages again and retry or reattempt in delivering. Amazon EventBridge is our serverless event bus service. So it simplifies the routing of events between the various AWS services, SaaS applications, and also custom applications. It logically separates the routing. You can implement using the various rules that you can apply to filter, transform messages between the different targets. It is a fully managed solution service that handles everything from event ingestion, delivery, as well as error handling, making it really easy to build a scalable event-driven application. And as with any other serverless service, you only pay for the events that you process. Amazon Pinpoint is not necessarily a messaging service, but it is a multi-channel marketing communication service. What that means is you're able to manage the targeted and transactional nature of multi-channel engagement to your customers using channels such as email, mobile push notifications, SMS, and it makes it really easy to run targeted campaigns in driving user engagement in using mobile application. So what it allows you to do is helps you understand the user behavior, define which users to target based on that behavior, and determine which message to send and when to send these messages. And at the end of the day, what it will accomplish is that it will deliver the right message to the right customer at the right time so that you can improve the engagement and the conversion of your campaign. Also provides integrated analytics so that you can view insights into how you were able to influence how customers interact with the applications and which customers were able to respond to the campaigns. Now I'm going to get into a little bit more into talk about serverless architecture and how it applies to modern application architecture and why customers choose serverless services in building a modern application architecture today. So today we are in the middle of a paradigm shift. So that means is in IT, our ability to do things at a rapid pace have been improving significantly with the introduction of infrastructure as a code or CI/CD pipelines or automated security and compliance and serverless. And the goal here is to automate and abstract away as much as possible from the customers, so-called the undifferentiated heavy lifting, so that the customers can focus on the value and building better products and ultimately winning more at your end customers. And the serverless is a key component that's going to allow you allow our customers to do things that are mentioned here, such as being able to decouple software system, which will lead to focusing on business logic and ultimately winning more customers. So why serverless, right? So why should customers choose serverless in building their solutions? And typically when this question is asked, the first reaction from the customers that we get is that serverless allows them to save cost. And it is a very compelling reason and almost always a conversation starter. But when you deep dive into the reason for our customers going serverless, the real driver is to increase agility and innovation at a faster pace so that our customers can achieve their business goals. It allows you to just increase the agility by shifting more of that operational responsibility in provisioning and managing servers, system maintenance, patching, and allowing our organizations to focus on innovating core products. And what is serverless, right? So Steve mentioned this earlier, but just to reiterate, these are the guiding principles that determine what a serverless is here at AWS. So having no servers to manage, and this doesn't mean that there's no servers that are stood up. It just means that our customers don't have to worry about managing them, scaling with usage. So being able to scale automatically without you having to think about it. So if you have those big events like Black Fridays or Prime Days, not having to think about and having time in advance to set up the various system and infrastructure, and allowing the AWS serverless services to automatically handle scale is what it provides. And paying for value. So you only pay for what you use. If you have an internal app that's running on-prem, and if you're a 9-to-5 shop, you're paying for all those hours outside of the business hours, which you're not using. And for serverless, you only pay for when your application is used. And the availability and fault tolerance is built in, so there's no need to architect for building across multiple AZs. This is all done for you. You don't have to worry about setting up auto scaling group or load balancing or setting up EC2 instances across multiple availability zones. That is all done for you. And while the Lambda is clearly at the core and center of the service architecture, it's when the different serverless services that come together and comprise a portfolio of your architecture when we see a significant advantage. So services around messaging, orchestration, or storage, when they all come together, that's when our customers see the big gains. And this visual gives you a good way of looking at the different options that you have and what they mean for you from an operational standpoint. And looking at the operational responsibility model, it basically implies that there are parts of the system that AWS would be responsible for, and there are parts that the customer must take a responsibility for. And in this example, we can look at database as one of the domains where you can utilize EC2 and leverage the power and flexibility of EC2 to run your own database. Or you can use something like RDS to be able to offload some of the management of the database to the database such as Aurora Serverless or DynamoDB to completely offload the database storage infrastructure to manage backend. And AWS has a wide set of serverless services. These are not the exhaustive list of services by any means, but the goal here is to provide you with more and more choice so that you can keep pushing the line in the direction that you're responsible for. Our customers are responsible for less and less as we manage more of the infrastructure from AWS. To recap, so what serverless mean for our customer? So by utilizing serverless, our customers will be able to gain that greater agility, be able to move fast as you're spending less on setting up infrastructure, less overhead in setting up servers or operating systems, better focus in writing code and building applications that matter to your business, increased scale, being able to scale at scale which you wouldn't able to do with your own data center. So things like big events, you wouldn't be able to run that infrastructure for 24/7. So it allows you to scale without much preparation. And more flexibility to build applications with reusable components and be able to scale independently and ultimately be able to bring your applications faster to the market so that you can win over your competitions. So here's an example of modern architecture that takes advantage of the serverless services and the patterns that I talked about earlier. And it does look a lot like the 3-tier architecture, but there are a lot of the same elements here, but in the data, logic, and presentation layer. But there are also a few key differences, such as, in the presentation layer, we have the Amplify, which allows you to build that mobile and front-end web application in a quick manner and be able to stand up the backend within a matter of minutes. Compute, utilizing Lambda to build that event-driven compute service which you can use pay as you go and no need to provision or manage service and be able to scale automatically. Messaging services such as EventBridge, where you can build that distributed and decoupled architecture, improving resiliency. And here we have AWS Fargate, which is a containers management, a serverless compute engine for containers, and this removes the need to provision and manage servers. And as Ben had talked about, the various different purpose-built databases that are focused on your business needs and not having a single database where it might not fit your use case. Okay, with that, I'm going to turn it back to Steve, who will provide a demonstration of the application that represents a lot of the modern application concept that we talked about and the services. Steve?
Yeah, thank you very much. I'm going to switch over to AWS Cloud 9, which is a cloud-based IDE for doing development. So let me just share that with everybody. So that looks like that's ready to go. So what we're going to do for the next 15 minutes, and it's almost exactly 15 minutes, is build a web-based React application from scratch using Amplify client libraries for the front end. And we're going to be using the Amplify CLI to build our back end, which is going to include Cognito, DynamoDB, and AppSync. So we'll go into a directory here, open up a terminal, and we're going to start by creating a vanilla React application using create React app. So we're going to call it amp demo for Amplify demo. And this is going to take a few seconds to build our project directory for us. And once that's done, we are going to just preview it inside Cloud9 to make sure everything's working okay. And then once this is done, just going to go up to the project directory. You can see the project directory is already configured for Git. We're not going to look at the console today, but it's very easy to bind this to the console and then have it deploy your applications for you. So we've run the dev server. We're just going to leave it open here for a little bit, let it run as we create our application. So the next thing we're going to do is build our backend. And to do that, we're going to go into our project directory, and it looks like this is not our project directory. So let's go into amp demo and type amplify and init. Now this initializes our project, and the Amplify CLI works by asking you a series of questions. So even if you're not terribly familiar with AWS or how it works, or you're unsure about what decisions to make, it's very interactive and allows you to build an architecture based on best practices, even if you're not terribly familiar with the environment. So what I've done there is create an Amplify project. It detected the fact that it was JavaScript and React. So it's going to build some scripts for me. And more importantly, right now, it's going out to the cloud and creating some IAM permissions and an S3 bucket to hold the metadata for our project. So this is going to take a few moments. Amplify CLI works with several platforms, including iOS and Android native, other JavaScript environments, and cross-platform environments like React Native and Flutter. Okay, our project is initialized. Now let's add an API. So there's two types of APIs in Amplify. One is a GraphQL supported by AppSync. That's the one we're using. And then we selected which type of authentication we're going to use, which is the Cognito user pool. Once again, there's a series of questions here. I'm just going to say, log in with username, and we'll pick the defaults for everything else. So for the GraphQL side, we're going to use one of the demo schemas, our to-do schema. And I'm not going to edit it here on the command line. I'll open it up in the IDE here, and we'll take a look at our GraphQL schema. So this is one of the sample schemas, like I said. It's extremely simple, as you can say. We're only declaring one data type called to-do. It's got a few fields. ID and name are required. Description is optional. And that model annotation is interpreted by Amplify. That's an Amplify annotation called a transform. And it says, take this data type, build the DynamoDB tables for it, write the resolvers for me and put them into AppSync, and build me all of the client-side configuration files I need. Okay. So I've answered the questions. I've looked at the status here. And when I do an Amplify push, it's going to build the CloudFormation templates and deploy AppSync and Cognito user pools to the cloud for me. Now it's asking here if I want to generate code for my GraphQL API. It's referring to client-side code in this case, right? So it's going to be JavaScript code, and it's going to create aliases for all of my operations, my queries, my mutations, my subscriptions. And I'll be able to access those from the Amplify client components. So through the magic of technology, we're going to speed up this CloudFormation deployment a little bit. Usually it takes around 5 minutes, but it's not a lot of fun to watch. So we're going to jump ahead in just a second here to the end of the deployment. So right now, the default provider is CloudFormation. We're doing a lot of work with our customers around the CDK, if you're interested in the CDK. And our stack is deployed now. And let's hop over to CloudFormation and take a look at the stack itself. You can see the resources were generated. The root stack is from our Amplify and init deployment. You can see we have some roles there. One of the nested stacks here, you can see we have resolvers. These are the programs that are generated by Amplify, so AppSync can talk to our DynamoDB tables. Okay, the other thing to note is, yeah, this is standard CloudFormation. Once you deploy stuff with Amplify, there's nothing secret about it. It works just like any other standard AWS resource. So now let's open up our AppSync API and let's look at what Amplify did to the schema. You can see here, we started with that one data type, but Amplify added all of our operations for us, most notably the queries, subscriptions, and mutations. It created new data types for us. It actually does pagination as well, which is really neat, and allows us to do complex filtering based on Boolean operations, which is not something that's built into GraphQL, but Amplify builds those capabilities into the schema and into the resolvers for you. Our demo is going to use both queries and subscriptions, and we're going to need to enter some data here. But to do that, we have to log in with our user pool, which doesn't have any users in it yet. So the first thing we want to do is take a look at our app.js file, our React application. So open that up, and we are going to add just enough Amplify so that we can log in and create a user using the client libraries. So we're going to do some imports here, and this first import sequence we do basically will turn this React application into an Amplify React application. So we import the base Amplify object from AWS Amplify. Next, we're going to import our configuration file that was generated by the Amplify CLI called AWS exports. And we're going to use that object to configure the Amplify object. The great thing about this is, since that auto-generated file contains all the information about your environment, this one line of code, this Amplify configure, is the last time you'll have to worry about configuring anything on the back end. Okay, so I've added the code without importing libraries, so let's take care of that right now. Okay, so the base AWS Amplify library is being added to our environment. And now, let's see, let's refresh this. Make sure everything's okay. Sorry, network's a little slow at the moment. And I'm just going to add a couple other libraries here that we're going to use in a second. These are higher order components built for React. This is our UI library for React environment. And it's going to include some cool things that allow us to log in and log out of our application, guard it using the Cognito user pool. Okay, so let's add those again. And the next thing we're going to add, let's see, it's taken a while to come up in the preview. We're going to import our UI library here. And there's a couple components there. First one is Amplify sign out, and the other one is a function called with authenticator. So Amplify sign out is a high order React component that we can just put in there with a tag, allowing us to sign out of the current user in our application. So let's put that right under the div separator. Okay, and then we're going to take that with authenticator function and pass it our component, our React app. And what that does is it creates a login gate for the application itself. In other words, the login, the component will not render unless we have a valid Cognito user pool user logged in. As I refresh the page, you can see because we have with authenticator, we now have a login. And this is probably actually the easiest way to add users to a Cognito user pool. Sometimes I do this anytime I create a user pool because it's just an easier experience. So creating a user called Alice, give it a password that meets the password rules, and it's going to do email validation here before it creates the user, which is pretty cool. So I'm going to go and grab a temporary email address and a fake phone number. Now, you can do phone number validation as well. In fact, you can customize this process any way you want. But the default behavior that we're seeing now is email validation. So I'm going over to that temporary email and waiting for the code to arrive so I can type it in here. Okay, paste in the code and confirm. And as soon as we confirm, we're logged in, and you can see we have our application, and the sign out banner is up there as well. So let's go to, now that we have a user, we can actually log in to our API on the console, and we're going to create some records or to-do items on our to-do list. So let's log in, and the interface here is the AppSync query interface in the AWS console, and I'm using a mutation. There's some tools here. There's some cheat tools here. If you're not familiar with GraphQL, that basically allows you to build a syntax easily, right? So I'm going to create a new to-do with a name and a description, creatively named first to-do, and the first thing everybody should do in the morning is make their bed. So every operation also requires what's called a selection set, or in other words, what fields you want returned. In our case, it was ID and name. So you can see we've successfully created the backend. Now that ID is a required field, but our resolvers inserted it for us, so we don't have to worry about generating unique identifiers. Okay, so now we have something in our database, right? We have a record there in our to-do list. Let's change our application so we can actually view this list. So I'm just going to get rid of this and magically paste in another React application that makes use of these libraries. So I'm not going to use sign out in this case. I'm still going to use with authenticator because I want to guard it. And you'll see I'm actually importing something called GraphQL operation. And then further below, queries and subscriptions. This is a function that makes use of the aliases that were automatically generated for us by the CLI. So we don't even have to use GraphQL inside of our application here. We have a connect object, which is a high order React object. We can define a query that gets run as soon as it's rendered, and we can subscribe to notifications, right? So every time somebody creates a new to-do item, it'll pop up on our screen automatically. So there's our subscription handler that will log it to the console and then add it to the list. Everything else here is HTML or JSX, more accurately speaking. So there's very little actual code here to generate this application. And you'll notice there's no GraphQL either. So the last thing we have to do actually is create a CSS file so it doesn't look like a developer put it together, although I have to say it doesn't look that good anyway, but it's serviceable. So I'm just going to paste in some CSS, and then we'll refresh the page here. Okay, so we're already logged in, so it didn't take us to the login there, but you'll see it automatically pulled in the first item there. The next thing I want to show you is how subscriptions work. So I'm going to add one more to-do item to the database here. Second thing to do is record a presentation and save that to the back end. Data comes back, everything looks good. And now as I pull over to the application, you can see it's showed up automatically. I didn't have to refresh the page. This is all happening behind the scenes using the Amplify libraries. So I know we kind of flew through that. You know, we had 15 minutes, but this is everything you need to do to set up, you know, a web application using a GraphQL API. And happy to answer any more questions about this. I think this is getting toward the end of the presentation, so I'll just hand it back. Thanks.
Great. Thanks so much, Steve. Yeah, it's really cool seeing, you know, that being put together, and with AppSync and DynamoDB as the backend, you know, what Steve just put together is an application that could scale to almost anything. So, you know, it's really simple, but can have a big impact for an organization. So we'll jump into a couple customer use cases that we have here at ClearScale. And just a reminder, in a few minutes, we'll have time for a Q&A, so post any questions if you have any. So the first customer we have is RF Smart. And RF Smart is a developer of mobile supply chain technology that gives companies clear insight into their inventory management and operations. So the challenge is that RF Smart supports customers around the world, and they wanted to reduce the inventory management risk and minimize disruptions by ensuring that their customer can easily switch to different geographical data centers at any moment. And so at ClearScale, we designed a system that used Lambda for the application layer and DynamoDB as the database layer. So doing this allowed RF Smart to take advantage of DynamoDB's global tables and have many instances of their applications running on the same data all over the globe, so that they'll have no downtime. And I'm going to show a diagram of what it looked like, and it's pretty simple. You know, this is simplified here, but we basically have data coming into you know, a DNS provider, Route 53, which is in Amazon, and then, you know, deciding where to point that. This is showing how the A/B failover went for their CI/CD. But what is important here is that DynamoDB automatically replicated their data to different data centers or different regions around the world, so that they could essentially run this and fail out of a region if they need to at any point in time, and have the exact same data with very little latency. So it's really an enterprise-ready tool that RF Smart was able to take advantage of. The next customer I want to show is Waves. And so Waves is a mobile dating app that enables people to express themselves fully in romantic relationships. And it's differentiated by from other mobile dating platforms by allowing users to specify their preferences up front, so that they only match with those who are comfortable with the same desires and activities. In doing this, you have to have tons of many-to-many relationships. So I'm setting the stage for our graph database, Neptune here. So Waves was, you know, having a challenge. They were growing out of or outgrowing their existing Google architecture, especially with storing and querying this data that they had. And then also Google's costs were growing, and so Waves was looking at moving to AWS and to take advantage of the AWS services to continue to grow their company. So ClearScale designed a solution that uses AppSync for the API, you know, what we've been going through this presentation, Lambda for the computations, and Neptune as the database of choice. So all of this is managed by Amazon, and so Waves no longer has to worry about scaling their infrastructure or managing systems while they focus on actually developing their product. The architecture allowed for Waves to horizontally scale without any effort while increasing the performance on the system. So searching, and this was done after the project, we did some benchmarks, and searching suggested profiles now takes less than 0.4 seconds to pull 100 random users out of a query of several thousands of total active users. So it was very quick, and they're able to actually pull these dating profiles together very fast. And then last we have Tryfin Labs, and Tryfin Labs specializes in Salesforce consulting and app and web solution development. So pre-launch, Tryfin Lab actually needed a solution to populate their product into separate AWS accounts. Each customer would have a different account essentially. And the solution had to comply with HIPAA and PCI DSS requirements, which can be tight sometimes. And all of the tools that we mention here are, or at least like API AppSync or Dynamo are HIPAA and PCI DSS compliant. And then they needed a creation of landing zone, which is basically an automated network infrastructure for these customers. They need separate accounts with their own CI/CD continuous delivery pipeline for each customer. And on top of this, the project faced really tight timelines, but still needed to lay out the details of the optimized platform, creating the design, and testing the results prior to deployment. And so we looked at building this, and we used Amplify with AppSync. It's essentially production ready with the compliances we needed. We created an AWS account vending solution that applied all the business needs and policies so that Tryfin Labs can easily govern the solution. We created an AWS template as infrastructure as code, and so that the option simplified the required security audits on the deployed infrastructure. We then provisioned the AWS tenants using our AWS services and APIs, and built this whole complete CI/CD pipeline for each account. And we looked at all of the code that was used and revised the code that Tryfin Labs had and expanded it to work and scale for production. And then again, we had the CI/CD pipeline set up in a way that you could plug in different variables for different customers to provide a really flexible and customized solution for each customer. So now looking at this, ClearScale does have some serverless and application development offerings. So the first one we do is a serverless workshop, and this really allows you to get insight into what serverless benefits and services that you could take advantage of. We understand basically your business case, and we try to tie that back to what services you could use and save money on. And once we do the serverless workshop, we usually go into an assessment. So we understand all your requirements and start building a serverless POC for you. And then we align all of your goals and success criteria for this POC. And then we jump into the actual proof of concept, where we'll build out the proof of concept for you and understand how this works with your team, how you guys are going to do logging and monitoring within serverless, and how this scaling affects and really benefits your team. And then after that, we go into full refactoring. So you can kind of take advantage of any of these offerings, but ClearScale is capable of doing all of those from the business side all the way down to refactoring entire applications. Great, so we'll do some Q&A if we have any questions. Let's see if we have. No questions on my end. Steve, do you have anything, or Daniel?
I don't see any questions.
Yeah, there was I got a question here. It's about Amplify, and question is, can you use the Amplify client libraries without using the CLI? So a lot of customers really like the Amplify CLI. We saw some of that with the React front-end code that was being written, but they may already have existing resources on the back end. And the good news is the Amplify client libraries can use existing resources. The one caveat is that the client components will expect the resources to be configured the same way that the CLI would configure them. And to help answer that question, actually the documentation in Amplify has a section under each category, like API, API analytics, those sort of things. That there's a section in the documentation on using existing resources with Amplify, so you can look that up and make it work that way. The other thing I didn't mention, it's probably worth mentioning, all of the Amplify products, except for the console itself, because that's an AWS service, but the CLI, the libraries, everything's open source. So if there's something, a feature you want to add, a provider you want to include, or you just want to troubleshoot it, it's all available on GitHub. So it's got a pretty robust community, a lot of developers involved, reassuringly, a lot of non-AWS developers involved to keep everybody honest and, make sure we have a good community of people promoting, the platform.
Great. So I'll move over. So thank you all. If you'd like, you could reach out at clearscale.com or sales@clearscale.com. If you have any questions for any of the presenters today, you can reach us there. They'll send our proxy any questions over to us. Thank you all for joining, and we'll reach out with the deck shortly. Thank you.